Hello and welcome to today's session. In today's session, I am going to make you familiar with decision trees. Decision trees are a popular and powerful tool used in various fields such as machine learning, data mining, and statistics. They provide a clear and simple way to make decisions based on data by modeling the relationships between different variables. What is a decision tree? A decision tree is a flowchart-like structure used to make decisions or predictions. It consists of nodes representing decisions or tests on attributes, branches representing the outcome of these decisions, and leaf nodes representing final outcomes or predictions. Each internal node corresponds to a test on an attribute, each branch corresponds to the result of the test, and each leaf node corresponds to a class label or a continuous value. Structure of a decision tree. Root node represents the entire dataset and the initial decision to be made. Internal nodes represent decisions or tests on attributes. Each internal node has one or more branches. Branches represent the outcome of a decision or test leading to another node. Leaf nodes represent the final decision or prediction. No further splits occur at these nodes. How decision trees work. The process of creating a decision tree involves selecting the best attribute using a metric like Gini, impurity, entropy, or information gain. The best attribute to split the data is selected. Splitting the dataset. The dataset is split into subsets based on the selected attribute. Repeating the process. The process is repeated recursively for each subset, creating a new internal node or a leaf node until a stopping criterion is met. Example: all instances in a node belong to the same class or a predefined depth is reached. Metrics for splitting. Gini impurity measures the likelihood of an incorrect classification of a new instance if it was randomly classified according to the distribution of classes in the dataset. Entropy measures the amount of uncertainty or impurity in the dataset. Information gain measures the reduction in entropy or Gini impurity. After a dataset is split on an attribute. Advantages of decision trees: simplicity and interpretability. Versatility, can be used for both classification and regression tasks. No need for feature scaling. Handles nonlinear relationships, capable of capturing nonlinear relationships between features and target variables. Disadvantages of decision trees: overfitting. Decision trees can easily overfit the training data, especially if they are deep with many nodes. Instability, small variations in the data can result in a complexity different tree being generated. Bias towards features with more levels. Features with more levels can dominate the tree structure. So pruning. To overcome overfitting, pruning techniques are used. Pruning reduces the size of the tree by removing nodes that provide little power in classifying instances. There are two main types of pruning. Pre-pruning, early stopping, stops the tree from growing once it meets certain criteria. Example: maximum depth, minimum number of samples per leaf. Post-pruning removes branches from a fully grown tree that do not provide significant power. Applications of decision trees. Business decision making, used in strategic planning and resource allocation. Healthcare, assists in diagnosing diseases and suggesting treatment plans. Finance, helps in credit scoring and risk assessment. Marketing, used to segment customers and predict customer behavior. Let me demonstrate an example of decision tree. So this is a particular Python program that I have implemented for demonstrating decision tree. Firstly, let me execute this particular Python program. So as you can see that a particular decision tree structure has been designed according to the input provided. So let me break down this particular Python program step by step. First is data loading. The Irish data set is loaded, which includes features like sepal length, sepal width, petal length, and petal width. Second is data splitting. The data set is split into training and testing sets, 80% for training and 20% for testing. Third is model training. A decision tree classifier is initialized using the Gini index and trained on the training data. Next is model evaluation. Predictions are made on the test data and accuracy is calculated by comparing the predicted values with the actual values. Fifth is decision tree structure. The structure of the decision tree is displayed, which shows the decision making process. When you run this code, it will print the model's accuracy and the decision tree structure. So I hope everyone must have understood what is decision structure. So thank you for listening me patiently. Let's meet during the next video or during the next session.